Before we work another problem, back on your journal, there are a couple other integrations that I asked you to show.
Yeah.
How do you do them? You're going to run into these in the middle of a trig substitution problem. So you're going to do a trig substitution, you're going to have done some identities on it, you're going to end up with a tangent squared in some problems. So how do you integrate a tangent squared? We obviously don't have...
This is a magical thing.
It goes back to a fundamental identity you have to use.
Sine squared theta over cosine squared theta.
Not that one. Which fundamental identity had tangent squared in it?
Secant squared minus 1.
Yeah. Number 7.
Then you change secant.
Said
1 over cosine squared.
you could change tangent squared into secant squared minus 1. Okay, dude?
Integrate secant squared.
Yeah, I should have put it theta. You can integrate that. Yeah, the integration of secant squared is tangent. So you end up with tangent theta minus, integrate the 1, you'll get a theta. So that tangent squared will change into that. You just have to realize that, oh, I can do that.
So wait, do we have like one of those on the test? If I remember right. That is really nice.
Okay, another one in the middle of your trig substitution problem, you're going to hit a 1 over secant squared. Okay, this is also a really easy one. What do you know about 1 over secant?
Sine and then cosine.
1 over secant would be cosine. So we know they're reciprocal, so you can change that one to cosine squared, and then do we know how to do cosine squared? Yeah.
Maybe.
We just did them yesterday's assignment. Yeah. Yes. Put your half out there, do the 1. This will be 1 plus sine 2 theta. And then I'm going to leave it from there. I'm not going to finish it. I just want you to know, to have on there, where do I go when I hit this and I'm stuck? So that's another one you're going to run into. We already put the tangent and cotangent integrations on there, right? Integrating tangent with negative natural log of cosine. You got those two. Okay, are there any others?
Cosine over sine squared.
Yeah. I knew there was one more.
And there's actually 2 more. Secant over tangent squared.
Oh, okay. Alrighty. If you run into a cosine over sine squared,
Can we turn that into a sine? Can we turn that into a sine, like 1 over sine?
easier than that. This is back to February.
Cotangent, cosecant. Right? It'd be cotangent, cosecant.
I can use substitute. What?
Cosecant, cotangent, and it turns into secant, or cosecant.
This is just you substitute a sine. The derivative is cosine. And then the cosine is going to cancel. Because I'm going to have cosine over u squared, which is going to give me u over cosine. Goodbye. And you'll have to integrate u to the negative 2. Okay. Once again, I'm not looking for you to work these out all the way. I just want you to have the, oh, what should I do next? So that will change to that. And then I'm assuming you could integrate u to the negative 2. Okay. And then the other one was tangent over secant squared? Secant over tangent squared. I can never keep that one straight. Okay, any suggestions? Will it u substitute? It looks a lot like the last one we just did. Because if I do substitute tangent, the derivative will be secant squared, and that won't cancel. So that doesn't work. This one, you have to do whoever a moment ago wanted to change. What other identities do use identities 1, 2, and 3. Change it into sines and cosines. And so you'll get a 1 over cosine and a sine squared over cosine squared. Make that a bigger line. And so then, yeah, when you flip that over, I will get a cosine squared over a sine squared, which will cancel a cosine. Seen that anywhere before? a little closer than that.
Oh, that one.
Then you have to do this to it. Once you get it to that point, you may do this. Now, I am okay with, since we know that, if you get a problem that's secant over tangent squared, and you just flat know it's going to change into cosine over sine squared, you may just make that hop. You don't have to do all the trig in the middle if you don't want to. But that means you have to have it memorized on the test that you can do that. You have to know that secant over tangent squared changes into cosine over sine squared. You have to know that, but yeah. Yes, you can do that. No. If you want to learn that, if you want to bother to memorize it, it works. If you don't want to bother to memorize it, then you have to do the trig functions on it. Okay, so we get to start another one. We'll see how fast can we do this. Eeny, meeny, miny, mo. Which one do I? Yeah, that one. Alrighty. I don't want that color.
I don't even know if I can see it.
I'm recording. Okay. Yeah, that's the one thing. Your generation has been spoiled by technology, and y'all don't memorize near as well. I've noticed that.
Oh, you go try those vocab quizzes.
Ah, that's true. Your memories have been expanded this year. That's a good thing. Okay. First of all, what tells you it's a trig substitution problem?
X squared
plus a number. Okay.
You're going to keep those perfect squares, right? On test and everything.
I usually do. I can't tell you every problem on your assignment is a perfect square. But I'm usually nice enough to do that much, yeah. Okay, so what do I use, or what do I substitute? My trig substitution, this has got the plus in it. This is the one that's a tangent substitution. It's added. Okay, but it's what number in front of tangent? So yeah, 4. Since that's a 4, you need that to be a 2. And so, okay, we will happily change all the x's into 2 tangents, including this x in front. And since it's squared, that's becoming 4 tangent squared. And the inside of the root is becoming 4 tangent squared theta plus 1. Have I got it all substituted? The dx, yes. So that's what I told you. You get too busy doing this, you forget to substitute the dx.
Why does this one go to 1?
Oh, because I miscopied it. Sorry. Because I know what's coming next.
How come you make some 4s closed top and some open?
Because for my entire growing up years, I made normal 4s, and then I discovered it's faster to write it that way, and so I do it back and forth. Old habits were one way, but I switched to the other. Okay, so derivative of 2 tangent is 2 secant squared d theta. So out here then, the dx has changed to 2 secant squared theta d theta. Then usually some miraculous identities and canceling will happen. So, okay, the 2's coming out here, the 4's coming out here. We all good with that much? Okay. Secant squared's on top. We got a tangent squared on the bottom. The thing is, what to do with the root. The root is where all the action's at. What should I do to the root?
The other side of the triangle.
Wait a second. Oh, never mind.
You can pull a number 2 out.
You always want to pull the number out of it.
Yeah, you want to pull it.
That's why we made it be the same number. So you want to pull the 4 out, which will really, however, be a 2. So I really have another 2 on the bottom.
Who proved this would work?
I don't know.
Like, why can't you just say x equals 2 tangent theta? Why can't you do that?
Because you notice it becomes this identity, the tangent squared plus 1. You figured out it's always going to become that identity.
Just because it becomes that doesn't mean it works.
Well, it does. I'm sorry. So that's a 1/4. Now, what do you know about tangent squared plus 1?
It turns into cosecant. It turns into secant squared.
Tangent squared plus 1 is secant squared in that square root.
Turns into secant.
So when I take it out of the square root, it is just secant.
And you cancel, and then you get that one identity we just had.
And that's secant squared. And yes, the secant, one of the secants canceled is, Alex, correct? Is it that one identity I just, or that one integration I just showed you? So you still have a secant on top, you have a tangent squared on bottom. And so this is where you can change it into sines and cosines, or you can memorize what it changes into.
Turn into negative
In the
1
interest
over
of time, can I switch it? I'm still not going to make it. So it becomes, oh, you're making a bigger leap. I want to know that when you take,
Oh, that's just cosine over sine.
that becomes cosine over sine squared. I don't want you to make a total leap.
You got a leap.
You can make that leap without doing the identities.
U is sine.
And then u is sine. So du is going to be cosine.
Cancel.
And somewhere here, yes, it's going to cancel. So I have u squared. The cosine cancels. And at long last, I have to integrate a u squared.
U to the negative 1. Or u to the negative.
Okay, I'm coming back to the top. 1/4 u to the negative 2. Okay. So I have an integration of 1/4 u to the negative 2.
Negative 1 over u.
We're almost done.
We're almost done, you're right. You want me to finish?
Yeah.
You want me to write you all? Okay.
I don't even need a pad.
So that'll be u to the negative 1 over negative 1 plus c. So it's negative 1 over 4u. Okay, what's u?
Sine, theta.
U is sine.
Change it back to
So you have to change that to 4 sine theta. Okay, is that done?
No.
Is that an x?
No.
We have to get it back to x's.
Yep, we're gonna go
How
back
did
to
we
secant.
get it back to x's?
So we gotta change it to secant.
We go back to our original substitution, and we draw a picture. Because we know that x over 2 in this case is tangent. And so I know that's opposite over adjacent, and I would get Pythagorean theorem, I'm going to get square root of x squared plus 4, which, yep, that's the original thing we had.
Awesome.
So if you look up sine in the picture and fill it in, you're there. Sine out of the picture is what, opposite over hypotenuse. By the way, they won't rationalize these. You can leave radicals on the top, the bottom, wherever you like. So I drew the picture, I flip it over, and I'm going to have a negative square root on top over 4x. Yeah, baby. Almost every problem you will have to draw the picture. Okay, so that was fast, sorry. We're doing all of this again. By the way, your work day, I'm not teaching anything new, so you have work day next class. And I will have your projects graded, that part of it.